There's a moment of pure terror that every British person on holiday experiences when they first plug something into an American wall socket. You're holding your laptop charger, staring at these two vertical slots that looked like they were designed by somebody who didn't know that the plug was supposed to stay in the wall. And you realize that somewhere along the way, these two nations managed to create completely incompatible electrical systems that seemed almost deliberately designed to frustrate international travelers. The story of how Britain and America ended up with radically different approaches to electricity is the story of two countries who were racing towards the same goal, bringing power to the masses, but they took completely different routes to get there. Now, to understand what I'm talking about, we need to go to the beginning of the electrical age, when electricity wasn't something that you took for granted, but a mysterious force that almost seemed magical. In the 1870s and 1880s, both countries were grappling with the same question. How do you take this incredible new technology and make it safe, reliable, and accessible to ordinary people? The British approach to this challenge was shaped by a particular blend of engineering caution, but also imperial ambition. British electrical pioneers like Sebastian de Ferrante and Charles Mertz were working in a country where everything had to be built to last. Safety was paramount, and the existing gas infrastructure had already established certain expectations about how utilities should work. When they started designing electrical systems, they were thinking about a nation of solid brick houses and users who expected stuff to work reliably for decades without too much fuss. This British engineering philosophy led to some distinctive choices that still define UK electrical systems today. The decision to use 240 volts as the standard domestic voltage wasn't arbitrary, obviously. It was a careful calculation based on efficiency, safety, and the practical realities of British homes. Higher voltage meant you could deliver the same amount of power with thinner wires, which was crucial in a country where every penny counted and where electrical installations often had to be retrofitted into existing Victorian buildings. The famous British 3-pin plug with its distinctive rectangular pins and built-in fuse represents this safety-first approach taken to its extreme. British electrical engineers looked at the early electrical accidents happening around the world and decided they weren't taking any chances. Each plug contains its own fuse, specifically rated for the appliance it's connected to. The earth pin is longer than the live and neutral pins, ensuring that safety grounding is established before any power can flow. The shuttered sockets also prevent curious children from sticking things where they really shouldn't. Now, you know how deep I go down internet rabbit holes for videos like this, and this electrical deep dive was one of the more complex research projects I've tackled. I'm talking about dozens of studies, historic documents, and statistics on electricity. There were literally about 50 tabs open at any given time as I tried to wrap my head around it. That's why for this project I started using today's sponsor, the Opera browser. Opera has actually completely transformed my research workflow. First, their Tab Islands feature was a game changer. I could group all my sources by topic. I had one island just for the history of electricity, another for UK versus US plug designs, and one for statistics. I could collapse or expand each island as needed to save space. Then there's the split screen feature. This was huge for fact checking. I could have my draft script open on one side and cross-reference sources on the other. No more constant window switching. And when I found a source I wanted to use, I could keep it open while writing and make sure I was getting the information exactly right. I also finally stopped losing track of what I was just reading because Opera's tab traces show these colored underscores that track your recently viewed tabs. The darker the underscore, the more recent the tab. When you're cross-referencing data from multiple studies like I was doing, it's amazing to see exactly which tabs you just came from. And here's my favorite part. I could keep music playing in Opera's sidebar player using Spotify or any of the 7 streaming services while deep in research mode, all without switching apps. Nothing kills research flow like having to hunt for your music controls, and the good thing is I can detach my player and move it around the screen and even outside the browser. You can also completely customize how your browser looks with Opera's Endless Theme feature. I prefer Midsummer. This makes it feel personal and modern rather than just another boring research tool. If you want to make research researching, or honestly any kind of serious multitasking way less of a chaotic mess, definitely check out Opera. My link is in the description and pinned in the comment below. Give it a try, and thank you to Opera for sponsoring this video and making my deep dive research actually manageable. Now let's go across the Atlantic when we talk about electricity, because American electrical development was being driven by different forces. The American electrical system was largely shaped by the epic war of currents between Thomas Edison and George Westinghouse in the 1880s and 1890s. Edison, backing direct current systems, initially promoted 110-volt systems, partly because he genuinely believed lower voltage was safer, but also because it gave his DC technology certain advantages over AC alternatives. When Westinghouse's AC system eventually won out, the 110 to 120 volt standard was already too entrenched to change. This lower voltage decision had cascading effects throughout American electrical development. Since you need more current to deliver the same power at lower voltage, American electrical systems had to be designed around handling higher current safely. This led to different approaches to wiring, different safety standards, and ultimately the development of the American electrical plug system. This plug system prioritizes simplicity and ease of manufacturing over the comprehensive safety features of the British system. The American approach reflected a different national character, one more focused on rapid deployment, mass production, and getting technology to market quickly. While British engineers were crafting individual plugs with built-in fuses and multiple safety features, American manufacturers were designing simple, standardized plugs that could be produced cheaply and plugged in easily by anyone. The two-prong American plug with its simple flat blades represented a philosophy that said electrical safety should be handled at the circuit level, not at each individual connection point. These different philosophical approaches created systems that work perfectly well within their own context, but become incompatible when they meet. The physical differences are obvious. British plugs are massive, chunky affairs that look like they could double as weapons, and they probably could, while American plugs are sleek and minimalist. But the deeper incompatibilities run much deeper than just the shape of the connectors. The frequency difference is the most technically significant divide. Britain, along with most of the world, settled on 50 Hz AC current, while America chose 60 Hz. This seemingly small difference affects everything from the design of electric motors to the flicker rate of fluorescent lights. But the choice of 60 Hz in America wasn't arbitrary either. There are reasons. It's mathematically related to the 120 volt system, and it provides certain advantages for power transmission and motor design. But it means that many electrical devices designed for one system simply won't work properly in the other, even with a simple plug adapter. And the voltage differences create their own set of complications. British appliances designed for 240 volts will either not work at all on the American 120 volt system or will operate at reduced performance. American appliances plugged into British 240 volt systems without proper conversion will often be destroyed in spectacular fashion, sometimes involving smoke, sparks, and an electrical smell that will make you question your life choices. Ask me how I know. But perhaps the most fascinating aspect of UK and US electricity differences is how they've shaped the daily experiences and people in each country. British homes with their higher voltage system can run powerful electric kettles that boil water in under 2 minutes, leading to a tea drinking culture that takes rapid hot water for granted. American homes with their 120 volt system are stuck with kettles that take forever to boil, which partly explains why American tea culture never really took off the way coffee culture did. The British ring main system, where electrical outlets are connected in a loop around each floor of a house, allows for multiple high-powered devices to be used simultaneously without overloading circuits. This system, combined with individual fuses in each plug, creates a redundancy safety system that British electrical engineers are quite proud of. American homes typically use radial circuits with central breaker panels, which is simpler to install and maintain, but requires more careful planning to avoid overloads. And safety statistics do reveal these differences in how the systems work in practice. Britain's elaborate safety systems result in fewer electrical accidents per capita. However, American electrical systems, while they are less individually protected, do do benefit from standardized installation practices and regular code updates that keep pace with technological changes. British electrical fittings are generally more expensive to manufacture and install, but they're also more durable and require less maintenance over time. For consumers, this means British people typically pay more upfront for electrical work, but they face lower long-term costs, while Americans get cheaper initial installations but may face higher lifetime expenses. And modern technology has created new challenges for both systems. The rise of electronics designed for global markets has led to more devices that can handle both voltage standards, but the plug incompatibility remains. The European Union's push for common electrical standards did put additional pressure on Britain to consider harmonizing with continental European practices, which of course it didn't, and America's massive domestic market has allowed it to maintain its own unique standards without much international pressure to change. The environmental implications of these different systems are becoming increasingly important as both countries grapple with climate change and energy efficiency. Higher voltage systems like Britain's are generally more efficient for power transmission and can more easily accommodate renewable energy sources. However, the embedded energy in existing electrical infrastructure is so massive that wholesale change to either system would create enormous environmental costs. Looking toward the future, both systems face similar challenges around smart grid technology, renewable energy integration, and the electrification of transportation. Electrical vehicle charging, for example, is pushing both countries to develop new high voltage, high current systems that go beyond traditional domestic electric standards. Ironically, these new systems may end up being more similar to each other than the traditional systems they're supplementing. Now that brings me to the end of this video. As always, I hope you learned something new. Thanks again to Opera for sponsoring, and I'll see you guys next time.